Good morning, how are you all? This is Dr. Nandi. Today we are going to talk about type 1 and type 2 errors in hypothesis testing. So I'll share my computer screen with you. Says water specimen are taken from water used for cooling as it is being discharged from a power plant into a river. It has been determined that as long as the mean temperature of the discharged water is at 150°F, there will be no negative effects on the river's ecosystem. To investigate whether the plant is in compliance with regulations that prohibit a mean discharge water temperature above 150°F, a scientist will take 50 water specimens at randomly selected times and will record the water temperature of each specimen. She will then use a z-statistic, which is given by z is equal to x bar minus 150 divided by sigma divided by square root of n, to decide between the hypotheses where h sub 0 is mu equal to 150 and ha colon mu greater than 150, where mu is the mean temperature of discharged water. Assume that sigma is known to be 10. Explain why the use of z-statistic is appropriate in this setting. So we will start with that. So if I move a little bit. Part A. The solution. The use of z-statistic is appropriate because sigma population standard deviation is known and n is equal to, sample size is equal to 50, which is greater than 30. Okay. Then in part B, describe type 1 and type 2 errors. Okay. So type 1 part, so let's do part B. Okay. So just this and make it better, looking slightly better. So part B, a type 1 error is made one error is to conclude that the mean temperature, that the mean water temperature is greater than 150°F. When in fact it is at most 150°F. Okay. Type 2 error. What is a type 2 error? So a type 2 error. A type 2 error is not to conclude, is not to conclude that the mean water temperature is greater than 150 degrees Fahrenheit, when in fact it is greater than 150. Degree F. So we are, even though the real state of the matter is the temperature is greater, water temperature is greater than 150 degrees Fahrenheit, we are concluding, or we are not concluding that the mean water temperature is greater than 150 degrees Fahrenheit, although in reality water temperature is really greater than 150 degrees Fahrenheit. Okay. So let's move this a little bit and then solve part C. Part C says alpha, what is this, the rejection of H0, the rejection of H0 when Z is greater equal to 1.8 corresponds to what value of alpha? To what value of alpha? Remember, alpha is the maximum probability of making a type 1 error. Type 1 error, or maximum probability of rejecting H0. Maximum probability of rejecting H0 when it is true. When it is true. So alpha is equal to probability Z greater equal to 1.8, and we can usually use our calculator to find this. So if we use TI-84, so we press the second key, then the verse key, and then number 2, which is normal CDF. So my lower is 1.8, my upper is 1E99, that is a very large number on the right. My mean is 0, my sigma is 1, and I paste enter and enter. Paste and hit enter twice. Okay. So my probability, so the alpha value is equal to probability of Z greater equal to 1.8 is equal to 0.0 0.036. Okay, that's your answer. That's your alpha value. Maximum probability of rejecting H0 when it is true. Okay. So now we are into part D. So let's read part D. Calculate the value of beta when mu is equal to 153. When mu is equal to 153. Okay. So we can solve for so in part D. Let me first read part D. Calculate the value of beta when mu is equal to 153. Okay. So so we know we will make part D. We will make a so let's keep alpha is equal to 0.035 and in that case probability of z is greater equal to 1.8 is equal to 0.035, which we determined in part C. Okay. Okay. So we can write z is equal to x bar minus mu sigma divided by square root of n. Okay. So this is 1.8 is equal to x bar minus the hypothesized value is 150 divided by standard deviation is 10 and sample size is 50 divided by square root of 50. Okay, so basically this is equivalent to 1.8 is equal to x bar minus 150 divided by 1.414. So now we will multiply both sides by 1.414. So 1 point times 1.414 is equal to x bar minus 50, minus 150, sorry. And then x bar becomes equal to 150 plus 1.8 times 1.414. And that results in x bar is equal to 152.546. Okay, so 152.546. Okay. Okay. So part D asked us if I go again and read it, calculate the value of beta when mu is equal to 153. Mu is 153. Okay. So in part D, we are assuming, let me read that again, that mu is 153. Mu is 153. Okay. Okay, so if I draw a picture, actually, this will be a good idea to draw a picture at this time. So actually, I should move this a little bit up. So we will draw the picture. So the picture is like this. Okay. Okay. So our sample mean came out as X bar. X bar is 153, 152.546. X bar, this one is the X bar, is 152.546. Okay. And this is the area of shaded region is equal to probability of type 2 error, type 2 error. Okay. And our sample mean, as I told you, is 152.546. Okay. So um, okay. So now they have given us, if I go a little bit up, okay, they have also given us in part D, the actual mean is 160. Okay. This is the actual mean. This center is at 160. Okay. So, okay. So, question is, what is the Z score? For what is the Z score for uh, for X bar equal to 152.546 when mu is equal to 160. Okay. Sigma X bar will remain constant at 1.414, which is sigma divided by square root of n as determined in before. Okay. So So the Z-score will be 152.546 minus 160 divided by this sigma x bar is fixed is 1.414. Okay, so this will be equal to, let me use my calculator. Let me get my calculator. Take a minute. So this is Z-score is 152.546 minus 160 divided by 1.414, and that is equal to minus 5.217. Okay, so now we have to find out what is the probability what is the probability of Z less equal to minus 5.217, and that probability will be very small, and that is your probability of failing to reject H0, when H0 is false. Okay, or beta, and that beta is equal to, you can use your calculator, so it will be normal CDF in TI-84. We are starting from a very large negative number, minus 1 E99. My upper bound is minus 5.217. My mean is 0. My standard deviation is 1. So the beta is equal to, let me create some space. So second verse normal CDF minus 1 E99 is the lower boundary. Upper boundary is minus 5.217. The mean is 0, standard deviation is 1. Paste enter and enter, and that value is beta is almost 0. Okay. So the answer for part B, the probability of making a type 2 error failing to reject H0 when H0 is false is almost 0. Almost 0. Okay. Almost 0. So I wanted to give you a tip. The tip is alpha is the probability of making a type 1 error, reject H0 when it is true, and beta is failing to reject H0 when H0 is false. Okay. 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 So in part D, what we did actually is we were given the actual mean temperature is 160. And we found the sample mean temperature from the previous, if we remember, we found the sample mean temperature X bar, X bar, X bar is 152.546. How did we achieve that? How did we get that? We assume the probability of making a type 1 error, that is z greater or equal to 1.8 alpha, as 0.035. So probability of making a type 1 error is 0.035. That corresponds to a z-score of 1.8. And from that information and knowing the standard error or the standard deviation of the sampling distribution, and knowing the actual mean temperature in the null hypothesis, we could solve for the X bar, that is the sample mean temperature. Now we were given, now we were given that the actual population mean temperature is 160. So then we find out what is the z-score for X bar equal to 152.546. And that z-score is very small, negative number, minus 5.217. So beta is the probability of failing to reject H0 when H0 is false. And that probability will be in the left of X bar equal to 152.546. And that is almost equal to 0. So our alpha is 0.035 and beta is almost 0. I will stop here today. If you have any question or comment, you can send me a note. I'll get back to you as soon as possible. If you like this video, please share this with your friend. If you like this video, please give me a thumbs up. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. Thank you for watching. Have a nice day. And I solve all kinds of math problems. So I'll be back next time with another interesting problem, interesting solution. Thanks for watching. Take care. See you next time.